So welcome back, guys. So here we have basically discussing Cisco Viptela SD-WAN. In Cisco Viptela SD-WAN, we have the controllers, right? We have the three different kinds of controllers. So for management, we have a controller. Okay, and this management controller is called as what we manage. The software is known as what we manage. Okay. Then, as I said, authentication is very important. So separate dedicated authentication server is there or a controller is there, and then this controller we call it as what VBond. Then, as I explained in the last lecture, that traditionally we had the control plane and data plane together on the WAN devices on the routers, but now the control plane is decoupled and we have a centralized control plane residing on a controller, and this controller we call it as what vSmart. So these are the three controllers we manage for management. VBond is for the bonding, orchestration or authentication. In simple term, it is for authentication. Every device must authenticate with VBond, vSmart. And then we have this device, we have this WAN edges. Okay. So these are the WAN routers. Now, who are the WAN routers? Like, are they traditional routers? So since originally this is Viptela, so this they were called as what? V edges. So Viptela, they had their own, they had their own range of WAN routers. In any organization, if some organization has 100 locations, all the 100 locations might not be identical. Some places there might be only 10 users working. Some place there might be 1,000 users working. So 10 users will generate less traffic. 1,000 users might generate more traffic, huge traffic. To handle less traffic, more traffic, there will be what different hardware routers, different capacities routers. Like how in Cisco we have 1900 series routers, we have 2900 series router, we have 3900 series routers. There are so many different series of routers available. Same way in Viptela also, they have also had a different range of this routers available. So we collectively, Viptela used to call them as what? V edges. We call them as what? V edges or VH, like that. Okay. Then when Cisco acquired Viptela, now Cisco is also manufacturing routers. So what about their routers? Can their routers also be used? Yes, Cisco routers can also be used. Only thing is that now on the routers, you need to remove the traditional iOS from the router, and then you need to have what SD-WAN enabled iOS on the Cisco routers. These WAN edges can be Cisco routers also. So initially, in the beginning, the Cisco routers, Cisco used to call it as what? C edges. C edge. So V means Viptela router or C means Cisco router. Now collectively, we call them as what? WAN edges. So WAN edges are nothing but what? The routers. It could be Cisco router, it could be Viptela router. Slowly what will happen? Cisco will phase out Viptela routers and they will try to market their own Cisco router with SD-WAN enabled iOS, not normal iOS. You cannot normal IOs, you cannot use the router for SD-WAN. So if Cisco routers need to be used for this SD-WAN, then then the customer has to upgrade the iOS. They need to download the SD-WAN enabled iOS from Cisco website, and they need to upgrade their routers. So it's a big portfolio of routers. These WAN edges. Collectively, we can call them as what? WAN edges. Now, yes, any device you need to configure. Initially, you need to configure something like that. So how these controllers will be, how these controllers will be configured in the very beginning. How these controllers will be configured. These are controllers means what? As I said, software. Now, if you take software, this vSmart and vBond, these controllers, okay, vSmart and vBond, they will have some console. This vSmart and vBond, they will have some console, like which on the server you need to have some console port, like how we have on the routers. So WAN edges also will have some console. There might be some console. Let's say so we can the administrator, he can connect his laptop through this console and he can configure some initial configuration. So this control vBond and vSmart will also have kind of some console on the server. But what about vManage? vManage, what do you require? You just require what? This vManage also, since it will be controlled, that means it will have an Ethernet port. There can be, since it is server, there can be multiple Ethernet ports, because usually servers will always come as a minimum, they will come with what? Dual Ethernet interfaces. There can be 4 Ethernet interfaces. When I say interface means, Ethernet means it can be Ethernet family. It could be Ethernet, it could be fast Ethernet, it could be gigabit. Doesn't matter. Like that. It will be Ethernet family interface. So we can connect a laptop like this also, and then using browser on the router on this laptop. Using the browser on the laptop, you assign an IP address to this interface. Like that. Okay. Same way, all this control, since vBond and vSmart, they are also ultimately they are also on some servers only. So can we connect, controllers using a Ethernet interface? Yes, like that. We can use Ethernet interface also, and we can configure using browsers also the vBond and vSmart initially, like that. But we manage, there is no console concept. We manage will be purely configured using what? Ethernet interface. And Ethernet interface, what's the difference? On a router, we have, console interface. The router console interface, we call it as what? We call it as what? Console port. We don't call it as interface. We call it as what? Console port. What's the difference between a port and an interface? What's the difference between a port and an interface? A console port, see, it is also an RJ45. If you've seen console port on a Cisco router or a switch or a Cisco firewall, it will be what? RJ45 interface. And Ethernet interface is also RJ45. So then why we call it Ethernet interface? We call it as what? Ethernet interface. Whereas this interface, we call it as what? Port. The difference is what? Port cannot have an IP address. Console ports, we cannot assign IP addresses. Whereas this interface, this Ethernet interface, you require what? An IP address. Using one interface of this vmanage, we connect a browser, and then you have to assign an IP address to this vmanage initially using a console, and then once the vmanage has been assigned an IP address, then using a browser we can connect to this interface and configure. So all the devices will have a console port initially to assign some IP address. Right. Now next thing is what, let's say these devices now need an interface to communicate with each other. I'm just writing C for console. These are the console ports, but this will be what interfaces like that. Now this interface, each this WAN edge is in different location. They are in different location. These are different, let's say 3 branches. So how these 3 branches will be connected? You require some service, you require some WAN service. And as I said, today now the most popular WAN service in the world is what? Internet. So you take up some WAN service from some service provider, internet service from some service provider, you connect this. And now this management, all these controls also need to have connectivity to this. This is a console interface. There might be a console interface. So this will be having IP address. So all will be having some IP. So using some WAN service like internet, or it could be MPLS, like that. Some WAN service, it could be internet or MPLS. Not necessarily it has to be internet only, it can be even MPLS also. So using this WAN service, what will happen now? All these devices now will have what? Reachability. All the devices will be able to ping each other. This reachability, we in Cisco Viptela SD-WAN, we call this as what? Underlay. This is known as what? Underlay. So underlay network you need to have before actual 16-bit SD-WAN will start. Now, this WAN routers ultimately behind them, let's assume that this first location is like HQ, headquarters. Maybe this could be headquarters like that. This could be maybe some location, some city maybe. Let's say this is LA. Let's say this could be on the East Coast, New York City. Headquarter could be maybe in some place. Dallas, Fort Worth, let's say. They will be in some location. Now, behind the router normally, so this side we call it as what? WAN. This is the WAN. Or let me, in one place itself I can write this is what? The WAN. And every router will have somewhat LAN. Every router will have a LAN. There can be multiple LANs also. There can be single LAN. There can be multiple LAN behind every router. And in this LAN, basically, in headquarter, maybe you have servers. There could be servers. And in the branches, there could be what? Users. So in traditional WAN, when one device is communicating with another device in another location using internet, we don't send the data normally. We don't send the data clear text. Why? Because if the data goes across internet clear text, there might be people on the internet. They might intercept the data. They might modify the data. They can tamper the data. They can misuse the data. So data is very important. Information we cannot send through internet clear text. So normally in traditional WAN, what people do? In traditional WAN, what people do? We set up what? A VPN. We set up what? A VPN across all these locations. So now the data goes through this what? Secured across the internet. Now, as I explained earlier, that in Cisco Viptel SD-WAN security is very important. So here also the data will be sent as what? Secured only. It will be going as encrypted only. So in traditional WAN, we are using what concept of what? VPN. Same way in Cisco Viptel SD-WAN also we have a concept called as what? VPN. VPN. Now the VPN concept is there, okay? Like that. So in Cisco Viptel SD-WAN also we have a concept of VPN. And this VPN concept is most important. Means nothing will flow without a VPN. Everything in Cisco Viptel SD-WAN will flow through what? VPN. So this underlay, we have this underlay initially, so that all these devices are communicating with each other. We get this initially all these devices are communicating with each other. This initial communication is like, let's say, clear text communication. But later on, as I said now, so there could be what? Controllers communicating with each other. Controller communication, we call it as what? East-west communication. And then maybe there is a possibility the WAN edges might be communicating with the controllers. So north-south communication is there. All this communication, as I explained you, that it will be what? It has to be what? Secured. So we have basically, there could be what? Management traffic. There could be authentication traffic. There could be control plane traffic. So for this also we have what? East-west communication or north-south communication. This communication also has to be secured. And that's the reason, initial, this communication, East-west communication, north-south communication. For that, we have something, one category of VPN, we call it as what? Transport VPN. Transport VPN. And this transport VPN is nothing but what? The underlay. So initially underlay will be what? Initially, we will just assign an IP address. This IP address will be what? Available on the internet. So they are reachable on the internet means what? Normally, let's say all will be having like public IP. They all have what? Public IP. They can be private also, depends. If if the WAN edges are, if I put a traditional router in front and I terminate this WAN internet connection on a traditional router and I put this WAN edges behind a traditional router, then this IP address can be private also. So it could be, and that's the reason I'm just simply writing right now IP, because this IP can be private, this IP can be public, depends on how the customer is, deploying them. But whatever reachability is there. Underlay means what? Nothing but what? Reachability. This reachability initially will be what? Clear text. But what is our requirement? The requirement is what? We want all the communication to happen what? Secured. And that's the reason what will happen? This interfaces now will be part of what? A VPN. That means the data has to go not clear text. The data has to go through tunnel. VPN basically means what? Tunneling. So we have something called as what? Transport VPN. Like that. Then we have the other VPN. Next VPN. Next VPN is for the actual data. See, user data. This user is communicating. This user is sending data to HQ. It is accessing some servers in HQ, or it could be the servers could be in data center. Users are accessing this server. They are doing their work. So their data is also going through secured, like that. Now, this is called as what? Service VPN. This is called as what? Service VPN. Service VPN. So we have basically two types of VPN. One is known as what? Transport VPN, and the other one is known as what? Service VPN. Transport VPN is first, and service VPN will be defined later, because it depends on what? How you want the service to be there. Let's assume now, I have, as I said, there are two segments. In the HQ, I have two segments. There is a possibility. Let me use a different color here. Let's say here, I have other set of servers also. I have other servers also here. Two different types of servers, two different types of applications. What could be a possibility? I want, users in some location to access both the servers. Servers in both the segments, like that. Or I want that, some branches, I want them to communicate only with this color. So let's say I will have over here also another segment. I want this pink color users. I don't want them to access the blue color servers. So it is like virtual, like this. And this is like virtual. I want them to communicate like this. I don't want them to communicate. I don't want all the users to access all the servers in the HQ. So see, I'm doing segmentation. Like in a traditional WAN, we have what? VLANs maybe. This could be what? Separate VLANs. We are keeping the servers in separate VLANs. Like that. So in VIPTEL SDWAN also the customer same requirement would be there. Like that. So I can what I have to do now, when if my requirement is that what there are two different set of servers and I want this two different set of servers to be accessed by different set of users, like that. So I have two requirements. So there will be what? Two service VPNs. I can have, let's say, this VPN, I can call this as what? Blue service VPN. Then I can, let's say, I can call this as what? Pink service VPN. So this is nothing but what? Service VPN. Both will be called as what? Service VPNs. And this underlay on which these actually service VPN traffic also will go ultimately through this WAN, and this communication east west north communication will also go ultimately through this WAN. So transport VPN will carry both. Transport VPN can carry ultimately, initially transport VPN will carry what? Maybe east west communication traffic. Transport VPN will carry north south communication traffic like that. And finally, later on, once this is there now, once east west communication has been established, once north south communication has been established, that means all these components of Cisco Viptel SD-WAN, all the controllers and the WAN edges, they have authenticated all the WAN edges, every component has authenticated with each other, and then ultimately later on what will happen? Service traffic will also go through this WAN service. Like that. Some people, some customers, they might say, no, we don't want like that. We don't want service traffic. So, the ultimately the organization, the information, the data. They say that no, we don't want this data to go through this. What is the possibility? They will say, okay, no, we will like to have what? A separate, let's say, we will for all the SD-WAN communication. All the SD-WAN communication, that means east-west communication and north-south communication. Okay, we don't want this traffic and this service traffic to go through the same link. We want a dedicated WAN service for service VPN, and we want for management. Ultimately, I'll simply, east, west, and north, south, I'll call it as what? Simply as what? Management. Management traffic altogether. This traffic, I want to keep it separate. Service means what? User traffic. I don't want the same WAN to be used for sending both the types of traffic. So what will happen? Some customers might go for what? They will say, we'll do one thing, we'll take one more WAN service. We'll take up a separate WAN. Okay. And what we'll do? We'll connect all these devices. So this is only management. Only management. Separate, only management traffic will be there. East-west, it could be east-west traffic, it could be north-south traffic, whatever. This SD-WAN components, these 4 components, the 3 controllers and the WAN edges, their management traffic, anytime, like I'm adding some interfaces, whatever, total management of these devices. I want that traffic to be sent separately, totally separate, like that. Now this will be an expensive affair, but yes, this is possible like that. And because of this, basically, we also have now in VPN, we also have something called as what? Management VPN. The third type of VPN. Like that. Management VPN and transport VPN. So transport VPN can, transport VPN can have management VPN or management traffic also, or if we want the management traffic to be kept separate, then even that for that also we will have a VPN. Like that. So altogether we have now in VPN we have three types of VPN: transport VPN, management VPN, and later on finally service VPN. When you have separate management traffic is totally separate. You're using separate maybe. So this van, maybe this van will be what to send the user data. This van could be, let's say this could be like 10 gig interface, 10 gig bandwidth. This is 10 gig. But for management, maybe the company might go for when only 1 gig van. Like that. This could be this management. For management, you don't require high speed. This will be low bandwidth. This could be low bandwidth WAN service because management traffic will not be every time there like that. You don't need to have management traffic all the time. Initially, only once you are configured, then later on, what will happen? Only the data will be going. Like in traditional WAN, we do routing only one time. We enable OSPF or we enable BGP or we do static routing or default routing. That is one time. After that, once that is there, unless and until we are adding a new segment or something, the routing is only one time activity. But user data will be flowing every minute once the connectivity has been established. So separate WAN like that. When organization will have this separate WAN for sending and receiving this management traffic, then this is called as what? Out of band management. This is called as what? Out of band management. Like that. But if management traffic is also going through this your underlay, if management traffic is also going through underlay and later on service traffic is also going through underlay together, like that, then this is called as what? In-band modeling. So organizations in the very beginning, when they're gone for the Cisco Viptela SD-WAN, they need to decide how they want the management traffic to be handled, how they want the east-west communication, controllers to controller communication, or controllers to the WAN edges communication, north-south communication, how they want this to be made. They want it in-band or they want it what? Out-band. If it is out of band, then out of band management will use what? Management VPN. Out of band will use what? Management VPN. If you have in-band management, then in-band management will use what? The transport VPN. Because transport VPN is ultimately, this company has taken this WAN service for ultimately sending user data, means the service traffic, user traffic, to transport this data. So when the transport WAN service is used to also send initially in-band traffic also, like that. Then we don't require a separate management VPN. Like that. But Cisco Viptela, SD-WAN, they have already thought of both the possibilities some organization, they want this data management traffic, east-west communication or north-south bound communication. They want this data to be kept totally separate. They don't want this to be sent through using the same separate private WAN they're trying to use out of band. This will be what an expensive effort. Extra, this will be expensive because for separate WAN service is needed. And maybe some organization will go, they won't think of cost, they will say no, it is more secure because we are keeping this communication totally separate. If tomorrow this WAN gets compromised, the transport WAN, the transport VPN gets compromised, your in east-west traffic and north-south traffic might also get compromised. Everything that can get compromised. So some organization they might go for what out of band management model, which will be expensive for them. If people are using in-band management, then this is basically economical. But in the very beginning, as I said, what in Cisco Virtual SD-WAN, nothing goes. Nothing will go clear text. Everything will be this east-west communication and this north-south communication. This is going how it is going? It is going through what? DTLS. DTLS tunnel. And service VPN traffic is going through what? IPsec enabled. So nothing is going clear text. So that's the reason most of the time organizations go for what? In-band management. This is more popular. Traditionally, like let's say I have two, you see on this WAN router, we have two types of users. In traditional environment, we have two types of users. There could be what one department, there could be two different departments like that. We don't want the communication to happen between two departments. In traditional LAN or WAN, in traditional LAN, what we do, guys, if I want that users of one department should not communicate with users of another department, what we do on the LAN side? On the LAN side, what we do? We have what VLANs, right? Like that. This could be in VLAN, this could be VLAN 10 here. This could be VLAN 20 like that. If it is a switch, on a switch we create what? Separate VLANs and we assign the ports to what? Separate VLANs. But now here we are talking about this. This is WAN edge. Means this is a router. On a router, if you have two different segments, you don't want the two different segments to communicate with each other. So what we do? On a router, you have a router here. Let's say you have a router here. Users here, I don't want them to communicate with the users here. I don't want them to communicate. So what we do?
VRF.
We create what? VRF, right? We'll create one VRF here. Maybe some VRF. Let's say VRF A. and I might create VRFD. So VRF used to have what names? VLANs, they have what? Numbers. 10, 20. What about these VPNs now? In Cisco VPN SD-WAN. What about these VPNs? Because ultimately here also you see, I have two different set of use servers. I don't want these servers to communicate with each other. I have separate set of users. Blue users will be communicating. I want them to communicate only with the blue servers. Ping users, I want them to communicate with only the ping servers. So my requirement is separate. So you see, I have two different types of service. So this is also, as I said, this is also what VPN traffic. This VPN traffic, user traffic, we call it as what? Service VPNs. So this VPN, whether it is transport VPN or whether it is management VPN, or ultimately there is what service VPNs. There will be service, there can be one service VPN, there can be 10 service VPN. There could be 10 different departments in an organization. So how the VPNs will be identified in Cisco VPTela SD-WAN? So Cisco VPTela SD-WAN, the VPNs are identified numerically. So we have basically, a range of numbers. And then range of numbers starts from what? 0 to 65K, 65535. So this is the range of numbers which we can use whenever we are creating, when we are defining these VPNs. And this 0 transport VPN, the number can be what? 0 is reserved for transport VPN. That means I can write it here 0. And then there is one more number which is reserved, like that. One more number which is reserved for management VPN. And that is called as what? 512. So 0 and 512, these are the two special VPN numbers which we cannot use it for service VPN. Service VPNs can have any number in this range except 0 and 1. 0 cannot be used and 512 cannot be used for service VPN. If you are later on, I'll show you, we'll create a service VPN. So when I am creating a service VPN, if I try to assign the number 512 or if I try to assign 0, it will give us error. It will say no, these two numbers are reserved for transport VPN or for management VPN. So 0 can be used for transport VPN, 512 can be used for transport VPN or management VPN. Also 0 can be used for management VPN and 512 also can be used. So we have choice. 0 and 2 are reserved for what? Transport VPN and management VPN. Organizations have to decide. For transport VPN, if separate out-of-band management is there, if out-of-band management is there, then what is the number they want to use? They want to use 512 or they want to use 0. Only two numbers are available because there is a possibility what only two in-band management or out-of-band management. If it is in-band management, then you don't require a management VPN separate. If it is out-of-band management, then you have initially transport VPN is also there. And there will be what? Management VPN also will be there. So numbers we have to decide, but we have to remember that 0 and 512, they are reserved only exclusively for transport and management VPN. And they are interchangeable. If I want, I can reserve 0 for management and 512 for transport. It is vice versa. But we cannot use any other number from this range for transport and management. Only these two numbers are reserved for management and transport. The rest all numbers from 0 to 65K or like from 1 to and 512 also we have to exclude. All the other numbers are only meant for service VPNs. Any questions on this?
Good.
Good. Okay. we need to get familiar with the terminology first. That's the reason now, since now we have already understood what is this way, what is north-south communication, what are the controllers and all. So now, we need to understand the terminology, the terms which will be used. That's the reason most important term is what VPN. Everything will be what VPN. VPN is like similar. The service VPNs are similar to like VLANs or VRFs. Service VPNs are similar to what VLANs or VRFs. Traffic between two service VPN cannot flow. Traffic between two service VPNs cannot flow by default. Like how traffic between two VLANs cannot flow on a switch, traffic between two VRFs cannot flow on a router by default. Same way, if you define multiple service VPNs, by default, there won't be any communication between the service VPNs. That's the reason. This, VPNs are nothing like we can, we can say if we can understand what is VRF, or if we have a understanding of what is VLAN, then VPN service VPN is similar to VLANs or VRF. Okay, that is one thing. So we have to define. We have to all, we have to think. What will be the service VPN numbers we want to use? What will be the transport VPN? Will it be 0 or 512? Like that. Or if you have out of band, what will be the management? If for transport I have taken 0, then management VPN will be what? 512. If I have taken for transport VPN 512, and then if I want to have out of band management, then for management VPN, I will have to use 0 only. Two numbers only kept here. Rest all will be service. Right. That is done. Okay. Now next, all these controllers, can these controllers will be in different locations? Or can they be in same location? Yes, these controllers can be in different location also, or these controllers can be in the same location, physical location I'm talking about. They can be in the same place, in the same segment, in the same VLAN. They can be this controller. Ultimately, these are servers. So servers might be basically on some, behind some router. They might be on a switch. They might be on a single physical switch, or they might be in different locations also. It makes sense, if we are talking about a big SD-WAN implementation, Cisco Viptela SD-WAN is is naturally or normally it is meant for what? A big implementation, hundreds of locations, thousands of locations, like that environment. It's a scalable solution, like that. Since it is a scalable solution meant for large enterprises and all, and when security will be paramount, then what is, some organization, what they will do, they'll keep these controllers in different locations. They might keep them in different physical locations. They might be in different cities. They might be in different countries, because we have internet. Internet is globally available. You just require what? Internet connectivity. So these servers can be in same location, in same city, or they can be physically in different locations. And naturally, the WAN devices, no, these are the actual company location. HQ will be in some city and branches will be in some other cities, like that. So WAN side, this is clear. But controllers, can they be in same location? Yes, controllers can be in same location, or controllers can be, can be scattered. Controllers can be on cloud also. They can be inside cloud also. Because see, controllers means what? Ultimately servers. So not necessary this has to be what? Physical server. They can be on virtual servers. So some companies, what they can do, they can basically take some cloud service from Amazon or Microsoft or Google. They can use any cloud service, any public cloud service available, and they can place their servers this controllers inside some cloud. Like that. So they can be anywhere, doesn't matter. So whether they are physical servers, whether they are basically virtual servers, doesn't matter. Their location can be in single location, all these controllers. They can be in different locations, all possible. Now thing is that, you know, how these locations will be identified in Cisco Viptela Cisco Viptela SD-WAN terminology. So we have something now called as what? Let me just clean up some space. We have now another term. It is called as what? Site ID. We have one more now term which is called as what? Site ID. And site ID is also what? Numeric. So every location needs to be, identified by a site ID. Every component in Cisco Viptela SD-WAN will belong to some site. Site means what? Ultimately, it will be in some location. So how this location will be identified? The location will be identified by something called as what? Site ID. Okay. It can be numeric, it can be any number. So like HQ over here, I can say HQ is what? Maybe, I will say site ID. I can say HQ is what? Site ID 100. Site ID. Or rather, basically, instead of writing it over here, because site ID is, for the device. Site ID, I can write it here. Because it is not related to any interface. This device is in some location. So in some physical location, in some physical, maybe in some city, in some particular place, doesn't matter. Either we need to logically identify the location of every device, right? This I can say, this is basically just writing SID now. This could be 100.
So
This could be 300. This controllers, if they are in the same location, then their site ID can be same. Or since they are controllers, I can, even though they are in physical different, as I said, they are on scattered, they are spread across in different parts of the world. Still, I can give them a common site ID also. So the site ID has nothing to do with the physical location. Even though if they are in the same location, I can say, okay, they are basically site ID, maybe let's say 1. Here also I can say they belong to the same site ID 1. Or if I want, I can make them different also. I can say this is 1000, this is 2000 site ID, this is 3000, or this is 101, this is 102, this is 103. If they are in the same location and still I want to give them a different site ID, yes, that is also possible. All the three controllers, let's say this, all the three controllers are in the same physical location. They are in the they are in the same switch maybe. these controllers are connected to a same physical switch in same location. And still, if I want their site ID to be same, I can keep them same. Or if I want their site ID to be different, I can keep them different. Site ID is nothing just to identify a location. This location need not be physical. We are just giving an identification to the location. That's it. So even if they are in the same physical location, they can still have site ID different. Or if they are in the same location, I want their site ID to be same. I can keep it same also. Same location, physical location is same. Does not mean that site ID has to be same. It is all to an organization how they plan their topology, SD-WAN topology. But this is compulsory. Transport VPN is compulsory. Site ID is compulsory. In the very beginning, we have to decide. Right? Okay. Maybe. Now next is what? Another important component in Cisco Viptela terminology, each and every device in traditional WAN, in traditional WAN, let's say in traditional WAN routing, we are using a routing protocol OSPF. If you are using a routing protocol OSPF, in protocol OSPF, in OSPF, how every router is identified? How every router is identified?
Area.
In traditional OSPF, each and every OSPF router is identified by what? Something called as what? Router ID. Right? So we have a concept of what? Router ID. Router ID is what? Some IP address. No two routers can have the same router ID. Router ID has to be unique. Now in Cisco Viptela SD-WAN also we have a concept of router ID. And this router ID is known as what? System ID. It's not called as router ID. So in Cisco Viptela SD-WAN we have something called as what? A third parameter which needs to be compulsorily, mandatorily defined. It is called as what? System ID. System ID has to be what? Unique. And it will be what? It will be nothing but what? An IP address. So same like router ID. Router ID is an IP address. So here also system ID in Cisco Viptela SD-WAN will be what? IP address ultimately. And it will be what? Unique. No two devices must have the same system ID. Because why it is called a system ID? Because collectively, in these controllers and these WAN edges, collectively, each and every component is known as what? Like a system. System device. Every device is known as what? System device. And that's the reason every device must have what? An ID, an identification. And it has to be what? A unique address, unique IP address. Right. Now this IP address can be virtual. This IP address can be means we don't assign, like in case of router ID, guys. In case of router IDs on a router, what we do, we create a loopback, correct? We normally create a loopback 0, and then we use the loopback 0 IP address as what? The router ID. But if you see in traditional WAN also, if you want to assign a router ID on a router, we have a command. In traditional WAN, we have the command router ID. With router ID, we can assign an IP address to an OSP router, which is not existing. It can be, just a fictitious IP address. It is what a fictitious IP address. In case of Cisco Viptela SD-WAN, this system ID, this IP address, in reality, it will be fictitious. It is not, it is not bound to any interface. The system ID is not bound to any interface on the device or on the controllers. So in case of Cisco Viptela SD-WAN, the system ID in reality is nothing but a fictitious IP address. It is not bound to any real interface. But it has to be defined. It is mandatory. So transport VPN, we have to decide. Management VPN, we have to decide. Service VPN comes later. But in the very beginning, we need to define what will be transport VPN. Will I use 0 for transport VPN? If I'm using for management, separate management out of band, then what will be management VPN 512? So that is the thing I have to define. Then on every device, I need to define what site ID. Then every device, I need to define what system ID. So far clear? Any questions? Any doubt?
We're good. I think Tom needs to head to dinner because he's working swings.
Okay.
But yeah, he's working swings this week.
Okay. So these are the basic terminologies which we need to, we need to have a clear understanding to begin actual, working on Cisco Viptela SD-WAN. You want me to continue further or we stop now?
I think we need to stop because Tom is working right now. So
okay.
He's working swings this week. So he's I think he just went to dinner now.
Oh, okay.
But he can do longer next week when he's working normal hours.
Yeah, because we'll need to, whatever sessions we lost, we'll cover up by taking session maybe at least half an hour extra every day.
Yeah, I don't know. I don't know, Beat, are you using a different type of mic? You kind of like sound like you're talking through a scuba mask or something.
No, I'm using the same headset earlier. My voice is coming different.
Yeah, it's not totally clear, but I adjust to it and I can understand you. Just it's not as clear as it could be.
Oh.
It's like kind of you go in and out sometimes, but I can understand you. So I'm just saying it could be better.
I'll try then. How about now? Maybe I just need to adjust the mic. Is it good now?
Yeah, you sound good. It sounded like you were going in and out before is what it was.
Okay. I'll just check. Maybe it could be, I don't know. Because your audio is very clear for me.
Yeah, I'd say from 1 to 10, your audio is like a 6 to me.
Oh. Let's see, I'll try to improve tomorrow.
Okay. I mean, like I said, you're definitely audible, but it could be better, just saying.
Let me check. I'll just basically
I'm just happy your internet is working.
Yeah, internet is there. It could be sometimes, yes, there could be some lagging maybe.
Yeah.
Audio, that could be reason because the same headset I use for my other lectures also.
Okay.
Occasionally, some students complain that someday my audio is not clear. That is possible, like that. But if that is the case, if it is like repeated, then I need to change the headset.
Yeah, and we need to get you a professional microphone. One of the radio ones they use on the radio.
Yeah. Those YouTubers, influencers, they use those kind of things,
Yeah, exactly.
They're doing
Oh.
the webinars and all.